What are the chemical properties of solder alloys for robotics? Imagine connecting tiny electronic parts in a robot with a metal that bonds perfectly, conducts electricity, and withstands the heat and wear of everyday use. That's what solder alloys do. They are the glue of robotics electronics, but their chemical makeup is what makes them reliable and safe. Most solder alloys are made from metals like tin, lead, silver, copper, and sometimes small amounts of aluminum or antimony. These metals are chosen because they melt at specific temperatures and from strong bonds with electronic parts. The main component, tin, makes up most of the solder and helps it flow smoothly when heated. Copper and silver are added to improve strength and resistance to corrosion. When these metals combine, they form a microstructure that looks like a tin-rich matrix with tiny intermetallic compounds. These compounds, such as copper tin or silver tin, are important because they influence how strong and stable the solder joint will be. Adding elements like aluminum can help control the size of these compounds, making the joints more uniform and less prone to cracking. The melting point of solder alloys varies depending on their composition. For example, a common lead-free alloy made of tin, silver, and copper melts around 217 to 221 degrees Celsius. Traditional leaded solder, which contains tin and lead, melts at a lower temperature of about 183 degrees Celsius. This melting behavior is key for robotics because it helps prevent damage to sensitive components during assembly. It also guides the soldering process to ensure the right temperature is used for each project. Chemical reactivity is another important property. When soldering, the alloy reacts with copper pads and component leads to from intermetallic layers. These layers help the solder stick well, but if they grow too thick, they can make the joint brittle. Lead-free solders tend to from different intermetallics than older leaded types, which can affect how long the joint lasts under stress. Corrosion resistance is vital for robotic parts that might be exposed to moisture or harsh environments. Silver in the solder helps prevent oxidation, keeping the joints intact over time. Good electrical and thermal conductivity are also essential. Chemically, these alloys conduct electricity efficiently and transfer heat away from components, helping robots run smoothly without overheating. Environmental concerns have led to a shift away from lead-based solders. Lead-free options, mainly made from tin, silver, and copper, meet strict regulations and are safer for both workers and the environment. They also perform well in robotic applications, offering a good balance of strength, stability, and safety. Choosing the right solder alloy with the appropriate chemical properties ensures that robotic circuits are durable, reliable, and safe. Whether building a prototype or assembling a complex robot, understanding these properties helps in making smarter choices. The right alloy will bond well, resist corrosion, and handle the heat and stress of everyday use, making your robotic projects last longer and perform better.